In section 4, we're still going to be writing equations of lines, but this time we want these lines to be either parallel or perpendicular to other lines. So by the end of this lesson, you should be able to write an equation of a line that passes through a point and is parallel to another line, and then do the exact same thing. Find the equation of a line that passes through a point and is perpendicular to another line. So, parallel lines lie in the same plane and do not intersect. Non-vertical parallel lines have the same slope. So these two lines right here, whatever the slope is, rise over run has to be the same. So parallel lines have the same slope. Remember, vertical lines have an undefined slope, but every vertical line is parallel to every other vertical line. Where perpendicular lines have to intersect at a right angle, so these two sets, you got this one and this one, and then they made it kind of confusing, but we have this one and this one. They intersect at right angles, which means that we have to find the opposite reciprocal in order to find the two slopes. So opposite reciprocal. Remember, this means change the sign, the opposite, and reciprocal means flip over. The other thing you can do is slopes of perpendicular lines multiply to -1. That's right here. The product of the slopes of two non-vertical lines is -1. So this example they give us is 4 and -1/4. If you multiply those two things together, you do get -1. So that's kind of a quick check. And then this over here talks about vertical and horizontal lines. Remember, this has a slope of 0 and this is undefined. So they're not really opposite reciprocals of each other, but every vertical line is perpendicular to every horizontal line. So you'll get questions like this, where it asks you to write an equation in point slope form. We're actually going to change this. I want it in y = mx + b. For the line that passes through 4, -1, and is parallel to the graph of this other equation here. So all we need this equation for is the slope. That's it. I don't care about anything else. So the slope of my line that they give us is 1/4. I need to find something that's parallel to this. So it's going to have the exact same slope, 1/4. So now this takes us back to the other problems we've done, where I've given you a slope and I've given you a point, and you have to find the equation. Now remember, you can use point slope form and plug this in, or you could just use y = mx + b and plug stuff in. It doesn't matter to me. Let's use point slope form. So I have y minus the y in my point, which is a -1, times the slope, times the x minus the x in my point, which is 4. Now let's not leave it like this. Let's put it in y = mx + b form. So we got to distribute. So you get 1/4 x minus 1. And then if I add 1 to both sides, I get 1/4 x + 0, or just 1/4 x. And then double check. These two lines would be parallel to each other because they have the same slope. You can also type this into Desmos and make sure that they are the same. And just like that, you'll get something that asks you about perpendicular. So write an equation in y = mx + b for the line that passes through -4, 6 and is perpendicular to 2x + 3y = 12. Remember, all we need this equation for is the slope. But right now it's in standard form, which means that the slope isn't sticking out to me. So what I have to do is convert this into slope-intercept form first. So if I move over my x's and divide everything by 3, this line becomes y = -2/3 x + 4. And remember, the only thing we need is the slope. I don't care about anything else. So the slope is -2/3. Remember, I want to find the line perpendicular to it. So what I have to do is take this and flip it over, so it's 3/2, and change the sign. So it's +3/2. That's going to be my new slope. So then remember, this takes us back to the old problems. Here's a slope, here's a point, find the line. Let's use y equals mx plus b for this one, since we use point slope for the other one. So plug in your slope, 3/2, and then we can plug in the parts of our point. So the y part of our point is 6, the x part of our point is -4, and we got to find b. So remember, you can multiply across, so you get -12 over 2. -12 over 2 is really just -6. And then if I add 6 to both sides, I end up with 12 for b. So this equation right here is perpendicular to this equation right here. And remember, you can plug it into Desmos and it will tell you if it's perpendicular or not. So the other types of problems you'll get will just give you a couple lines and ask you if they are parallel or perpendicular. So what you need to do for these is compare all of the slopes. If they give you one like this, it's pretty awesome because the slope is looking right at us, it's 3. Or even one like this, we should recognize that this is a horizontal line. So my slope is 0. This other one is in standard form. So before I can compare the slope, I have to get it in the other form. I am going to subtract 6x from both sides, and then divide everything by -2. So we get y equals 3x plus 1. So now that it's in this form, it is easy to find the slope is 3. So let's take a look at all of these equations. These two right here would be parallel to each other. They have a slope of 3. But this guy, just a horizontal line, isn't going to be parallel or perpendicular to any of these. So we'd end up with, if we were looking at a graph, rough sketch, one would look like this. This is the -4. One would look like this, because it's the 1. And then the other one, the horizontal one, would look like this, because it goes through at 4. So these two green ones, or these ones here, are parallel to each other, but that horizontal one is not parallel or perpendicular, because it has a slope of 0. So you have a couple problems to prove here. This page is kind of a summary of things. You notice me using these symbols. These two lines right here means that something's parallel. You can think of it as the two L's in parallel. And then perpendicular, remember they cross at a 90-degree angle, so there's our 90-degree angle. It's basically a T upside down. Make sure you write down any questions you have and we can go over them in class together. Enjoy your night.